Welcome to our second CrowPi lesson. In our previous lesson, we've been talking about the buzzer module, how it works, and how to control it using the GPIO out function. Now we'll combine the buzzer with a button. So what is a button? A button is basically like a bridge, like a switch. Use the button to control other modules. When a button clicked, you can do multiple functions. For our lesson, we'll use a buzzer. So when we click the buzzer will buzz. It's important to say that in our circuit, the button and the buzzer are not connected together. But we use Python and our CrowPi to connect them programmatically together. So the button works on GPIO 37 and the buzzer works on GPIO 12. The button will be GPIO in because we get input from outside. A button click is input. A buzzer is output. So when the button clicked, we get GPIO input on GPIO 37 and then we send GPIO out to GPIO 12. And that's how we make the buzzer work by a button click. Let's go into our CrowPi and see how it works. Okay, we're back at the CrowPi. Let's have a look which modules we're going to use. So as our previous lesson, we're going to use the buzzer module, which is located right here on GPIO 12. And this time we are going to use a button, which is on GPIO 37. We have many buttons in our board, but for our specific project, we're going to use this button, the up button, on GPIO 37. We need to make a very small modification to make the button work. As you can see, we have switches here. The switches enable us to turn on and off multiple sensors. As the Raspberry Pi doesn't have enough GPIOs for all the sensors on our CrowPi. So what we're going to do is turn on all the buttons on the switch, like this, one by one. After they all turn on, we can use our script. To do that, we go into our CrowPi folder, same as before. And we'll look for a file called button buzzer. Let's double click that. Alright, let's go line by line and see how it works. As we mentioned before, we import the Raspberry Pi GPIO library as GPIO and the time library to make it stop and sleep. Then we configure button pin and buzzer pin. On our previous lesson, we only configured buzzer pin as GPIO 12, but this time we are going to configure another pin, which is the button pin on GPIO 37. So in total, we have two configurations, button pin and buzzer pin. Then we are going to configure the GPIO mode. We're going to set it to GPIO board, same as our previous lesson. As we mentioned before, in all our lessons, we will use GPIO board and not GPIO BCM, which is also available mode for use. Then we are going to set up the buttons and the buzzer. So as we can see, the first setup is the button pin. Unlike the buzzer, which is GPIO out, we're going to set up the button as GPIO in because we're going to get input from outside, which is the button click. We set it as pull up down, which means we can pull it up or down, click it and hold it or release it. So pull up down, GPIO PUD up, same as here. Make sure to mention it, else the example might not work. Another setup we are going to use is buzzer pin GPIO out, same as we used in our previous lesson. Then we are going into a loop. A loop means we continue to do this unless keyboard interrupted, and then we clean the GPIO pins. To interrupt the keyboard, we need to press Ctrl C on the keyboard. Until we do this, the code will run continuously. While true, forever, we will run the following code. Let's take a look at our main code. If GPIO input button pin means if we click the button equals to 0. Equals to 0 means low. So you might ask yourself why the button is low but the buzzer is high to activate. Well, our PCB is not quite the same. Some sensors require different configuration because our PCB is pretty complex. So we need to make some changes and make the input high and low at the opposite side. So as we said, when we're gonna input it, when we're gonna press the button, it's gonna be low, 0. So if GPIO input button pin is low, then output buzzer pin GPIO high. which means make a buzzing noise. Else, if the button pin is high, which means we don't click it, output buzzer pin low, which means don't make any buzzing noise. And we keep doing it forever until you click Ctrl+C on your keyboard, and it will run keyboard interrupt command and will clean our GPIO pins for later usage. Now, after we checked all our code, let's take a look how it actually ends. Let's click the green button, same as before, run current script. As we click it, the script will start running. At first, you might not notify anything, but if you've done everything correctly and you click the up button, it should make a buzzing sound. You can click it multiple times, a different frequency, and it will still buzz every single time. You can try to make your own program, for example, count how many times you click a button. What else can you come up with? Let us know later on. Thank you for watching our second video and hope you enjoyed.